We had two presentations in acute myelogenous leukemia. The first one was AML in newly diagnosed patients with the next-gen sequencing. And the objective of that study was to reconcile that enormous data set that we get in NGS. And so how could we come up with a meaningful conclusion with all those different tests, all those different genetic mutations that show up in the NGS testing? So what we did was we looked at, we collected all the data of patients who went through treatment, had cytogenetics and next-gen sequencing, and all the other parameters that we typically look for in studies. And then we looked at the next-gen sequencing. There are about 54 targeted sequences that we typically look for. As you know from the TCGA data, there are about 13 genes that are important in the leukemogenesis. But we looked at an extended set, and these sets could be all put together or derived from the TCGA data itself. So if you look at those, and let's say give you an example, you have a patient who's FLT3 positive, who's NPM1 positive, has DNMT3 positive. So how do you prognosticate? How do you predict the outcomes of these patients with the data that's available? And then you scratch your head and said, I don't know, it could be bad, it could be good. And so what we did was we looked at the prognostication of each of these genes based on the TCGA, the supplementary material from the New England Journal, and we gave them scores, a 5-point spread score. And we took each patient's genes and we gave them a score, -2 for the best prognostic factor like NPM1, and +2 for something that had the poor prognostic factor like FLT3 or TP53. And then we tabulated them, and then we had a summation of all these numbers, and we came up with a scoring system. Interestingly, we divided the cohorts into the traditional prognostic classification, which is cytogenetics, into the good risk, which is the inversion 16 and the 821 translocation, and the poor risk, which is complex karyotype, and the intermediate risk. The intermediate risk are patients who are typically have a normal karyotype, either an XX or an XY with 46 chromosomes. So what we did was we put those numbers in there and then ran a statistical analysis, and we realized that for the poor prognostic cytogenetic group, it didn't matter, that these NGS didn't really matter, which is what we always thought about. But in the intermediate risk, those patients who had a normal karyotype, we tabulated them, and for those patients who had a score of 3 or above, when we ran the statistics, they had an increasingly higher mortality rate. So this is completely different from the ELN data sets, which show you the intermediate classification is ELN class 1 and class 2, where you have a set of genes like FLT3, NPM1, CEBPA. But in this exercise gave us an extended set of genes and a prognostication in the intermediate risk, which I thought was very interesting. Of course, this is at a single institution, 100-patient data, and we hope to validate this with larger cohorts.